Okay, welcome everybody to our first webinar called Common VFX Workflows in CityEngine and Houdini. Thank you all of you for joining us today. This 1-hour webinar will feature product specialists from ESRI as well as a user story from Ellie Ansell, formerly of Framestore, now currently Groom and Character Effects TD at One of Us. Joining us from ESRI is Taisha, Fabricius, 3D evangelist, and Simon Haegler, who is a senior software developer. So hope you guys are excited and ready to learn some cool CityEngine tool tricks. And I'm going to kick it off to Taisha.
All right. Okay. So let's do this and share my screen. Sharing my screen. Can someone let me know if they can see this?
Looks good.
Cool. All right. So yeah, hi everyone. I'm Taisha, as John mentioned. I'm a 3D technology evangelist at ESRI, and I'm really excited to be part of this webinar today. So thank you that you all took the time to join us today, and thanks a lot to the VES for giving us this opportunity. So yeah, I'm going to talk to you for a couple of minutes first up on what CityEngine actually is on a high level. And then Simon will take over and dive a bit deeper into the more technical stuff. And then Ellie will finish off this webinar with a CityEngine use case for Netflix's The Witcher. So yeah, let's start by getting the ball rolling with a couple of clips showcasing some CityEngine work in the entertainment industry. So I hope that all played back for everyone more or less okay, but I think we're all pretty used to the Zoom video quality by now. So what is CityEngine? So CityEngine, it's a procedural, so procedural means parametric, rule-based 3D modeling software that allows us to generate accurate data-driven representations of cities and surrounding areas, but also to create real and fictional cities from scratch. So CityEngine is typically used to model urban environments, and it's commonly used in like architecture and urban design and visualization in those sorts of fields. But obviously, and yeah, that's the reason why we're all here today, CityEngine is also used to create city environments for the entertainment industry. So how does it work? At a high level, a typical CityEngine workflow will look something like this. So on the left here, we start off with our data sources. There's lots of different data sources available to you, either through ESRI or through available open data. So that means that it's data that's freely available, or also through our ESRI partner companies. And then moving one step on, you bring this data into CityEngine, and CityEngine will create the different features for you. So then to visualize your data more realistically, if you move one step further again to the right, we'll apply something called rules. So the unique CityEngine scripting language is called CGA. That stands for Computer Generated Architecture. And within CityEngine, we have some rules that are already available for you, but you can also easily script your own ones too, depending on what your requirements are. And then, final step there, you can output your models to a variety of different formats. And yeah, today we'll obviously be looking into one particular use case with Houdini. The way that we typically create 3D models in CityEngine starts by bringing in 2D shapes or building footprints, and then applying the CGA rules onto the shapes to create the 3D model. And if the data that you've brought in already has attributes, then CityEngine can use those attributes to determine what the resulting 3D model will look like. And yeah, the great thing about working procedurally is that you can tweak the rule and regenerate your model and work through this sort of iterative process until you get the result that you're after. So yeah, maybe you're asking yourself, so why should I use CityEngine? I'm going to pose a question here. So how hard is it actually to model a city? I'm going to try and answer this one as best I can. So I'll start off with the buildings. So if we take, for example, Redlands, which is a small town where the ESRI headquarters are located, which is about 1 hour east of LA. And the population there is around 70,000 people, but it already has 26,000 or over 26,000 buildings. Next example is Orlando. So that has a population of around 250,000 people, and it already has over 100,000 buildings. Or the third biggest city in the US, Chicago, has over 1 million buildings with a population of around 3 million people. So in total for the US, we're looking at well over 100 million buildings. So then let's quickly calculate how long it would take us if we were trying to manually model these buildings. So if we assume that you can model one building in about 15 minutes, give or take, then even then you'd need to invest 6,500 hours to model a small town like Redlands. For Orlando, it would be 14 man-years of work, or 27,500 hours. And then if you dare to model a city like Chicago, it's a whopping 300,000 hours, or 150 man-years. But yeah, that's not all that there is to do. It doesn't stop there. A city has more than just buildings. So a city also includes things like facades and lights and windows, street furniture, roofs, rooftops, all those things. And so, yeah, this can easily become a pretty time-consuming and very tedious production task. So yeah, that's kind of why it makes sense to use smart technology instead of tedious manual labor. So in this diagram here, you can see on the y-axis, you have the total cost or hours. And then on the x-axis, you've got the amount, quality of content or design. So instead of having this relationship of more buildings, more time correlation, we can break it by using procedural technology. So then, yeah, we first define the rules and the libraries and the things that I just briefly touched on before, so that we can create these beautiful cities with thousands and thousands of buildings without adding all the extra time. And yeah, I'm just going to quickly show 2 user examples here. My first one is from Big Hero 6. So yeah, this is based on real parcel data from San Francisco. It's around 83,000 buildings. And yeah, then at some point, the director wanted to exaggerate the topography. And so using procedural techniques, the terrain was exaggerated 1.5 times. And then the city was regenerated. And so that obviously made for a much less time-consuming workflow by doing it that way. The next thing here is Zootopia. So the vibes for Zootopia, and I'm probably some people in the call here who actually worked on this, but so correct me if I'm wrong then. But yeah, so the vibes for Zootopia was, although it's a fictional city, it should feel like a real city. So yeah, again, real world parcel data was used. And then from this, like the streets and the city layouts and things like that were built out. So the idea behind this workflow was really to work with sort of real geodesign principles and to make the city feel as believable as possible. So yeah, that's my part. At this stage, I'd like to hand over to Simon.
Thank you.
Can you grab control of the share? Yeah.
Let me
Perfect.
switch to my introductory slides. Okay, can you see that fine?
Looking good.
Okay, so hi everybody, name is Simon. I'm a software developer on the CityEngine product team, and I have like two parts here to present to you. First, I'm going to quickly establish a bit deeper look into CityEngine UI, and then we'll talk about the 2 most common VFX workflows we saw or we see in our customer base. And then I'm going to take you into a hands-on demo how we transport CityEngine scenes through USD into Houdini and what the possibilities are there. So this is CityEngine desktop application. It's a very similar concept as you know from other tools like Maya and Co. You have on the left upper side, you have scene layers. On the lower side, you have your file browsers. On the right-hand side, you have an inspector. So that's common concepts. And then in the middle, yeah, that's a procedurally based urban planning scene. And basically using the components Taisha introduced before. So GIS and parcels, layers, terrain layers, and then procedural modeling. So the geometry you see, or even the trees and everything, this is placed in the scene by scripting, so by procedural language, the CGA, as introduced by Taisha. And then just to give an example, that's then how such a scene looks. For example, in this case, we exported it to Unreal and did a simple camera move here. And that scene, I will come back to that and we'll use it as a basis to export it to Houdini through USD. Let's take a step back here and look at the VFX workflow with CityEngine, or from a very high, it's like bird's eye view. From there, it's actually very similar to other packages. You import data, you edit them, you export data. You have layers, as in Photoshop or Maya. The special thing about CityEngine in terms of layers is that these are actually all connected. So if you change the terrain here, you can choose that your streets will automatically adapt to changed terrain, and therefore also your buildings will adapt to the changed streets. I will show you that in a second, in the second part, I mean. And then you can export to whatever pipeline tool you need. So we see kind of 2 basic workflows in our customer base to deal with CityEngine generated environments. On the left-hand side, or let's start at the top. So what's common to them both is exporting elevation maps or terrains as grayscale bitmaps or quad meshes, exporting street layouts as graphs through DXF or formats like that. Parcels you could export as shapes, even the rules themselves. So the CJ rules you wrote can be exported and used in some of our plugins, but plugins, that's probably the topic for a different webinar, which I'm happy to do at some point. So then on the lower left side, a pattern we often see is that people generate a city fully in CityEngine, and then they use our Python API to write a lightweight point file, which is annotated, so where each point is annotated with a transformation matrix, with a studio or pipeline specific path to the hero asset, things like that. So I guess you know this concept from other packages as well. And then on the other hand, the people are also using the full geometry export with Alembic and now USD in the latest CityEngine. And what this enables is that you can export also the geometry which is very specific to CityEngine. So like street sidewalks, curbs, roof geometry, which depends again on the sidewalks, on the street layout. All these things which are hard to pre-model and just instance with our procedural language. And obviously that's the logical reason is that people start to combine the two workflows and use both. So we look at some examples of these two and the mix. So one of them is, as Taisha just showed, is Zootopia. There they basically use CityEngine to lay out the whole city based on real parcel data. That's these guys. They're obviously blended over and modified and tweaked a bit. And then they use the pre-modeled hero assets like these, which are then instanced out or layouted with CityEngine. So here's a screenshot of that. You see all these pre-modeled assets, but they are placed and chosen by the CJ modeling language. And so by quickly playing around with random seeds, you see that you can modify the scene quite drastically, or some parcels. And that's one of the strengths of CityEngine here, to kind of be this layout engine almost. And then these are a few shots from Zootopia where CityEngine was used in the background to fill up the city environment. Same here. Also here in the background. And again here, you saw this video from Taisha. Oops, I just want to pause it, maybe there. So here in Big Hero 6, Disney did a similar thing. They pre-modeled kind of floor components. So this roof, this floor, it's hard to see, this floor, they were all modeled in a way that they can be combined in various ways using the language again, CGA. And so that allowed them to have a lot of variation and or variation enough for background buildings in the shots you saw earlier. Now on the other side, we have workflows which just use geometry directly from CityEngine. So this one here, I believe they even used our old RenderMan exporter and actually used RenderMan to then further process the data. And this is really as a developer, I was like astonished, because RenderMan is not really a format for interchange, but to render. But that's cool. They pulled it off. Great stuff. And also Total Recall used the workflow completely with geometry from CityEngine. And then the mixed workflow, which is probably the most interesting one and a powerful one. So for the Guardians of the Galaxy, they used this hybrid approach. They did the layout, concept art, brought it over into CityEngine. They had this concept of density boxes, building shells, high resolution geometry, and textured or shaded geometry. And they used these to kind of build up the city. So they had these boxes, density boxes for hero buildings. So they just used the extrude command in CityEngine to kind of get a feel for the hero area and how dense it would look. And then they used the pre-modeled building shells and distributed them again with the CJ language And for the rest, for the streets and things, they directly exported the geometry from CityEngine. And that's one of the final shots. So as usual, with our nice city layouts, a lot of it is hidden behind VFX, explosions and smoke, but that's just how it is, right? Cities always seem to be destroyed these days. All right, now it's time to switch gears. I'm gonna switch to my video presentation. Let me just switch to my video player here. And now I would like to talk to you hands-on how one can export from CityEngine and go into Houdini. And I will use the urban planning scene I showed you just before the beginning. So let's get this started. So this demonstration is based on a city planning project. This was done by our virtual reality and ArcGIS urban product teams at ESRI R&D Zurich. We could obviously have used the procedural power of CityEngine Houdini to create some crazy sci-fi city as well. But I placed this demonstration at the border between urban planning and VFX because this reflects in a way what we see often in our customer base, that many movie or game productions these days are actually starting with real world data. Special thanks goes to Ioanna Mitropoulou for all her work on these building designs and the CityEngine work there. So this project is about redeveloping Dorchester Avenue in South Boston. I hope I pronounced this correctly. The basic idea was to improve walkability, public transport, and add more green spaces. So inspired by this, we took the raw GIS data provided by the urban planning department of the city of Boston and enhanced it with CityEngine with our own building designs. And in the original project, we exported it to Unreal Engine. And now I would like to show you how this is basically feasible to, or how to repeat this process from CityEngine to Houdini through USD. So we start the CityEngine scene by importing the raw GIS data provided by the Boston Urban Planning Department. This will allow us to correctly georeference the scene in case you want to align more data later on. So it's useful to stay georeferenced in CityEngine as long as possible for such scenes. In this case, we start with large polygons, which give us the boundaries for groundwater and greenery. So these are just references, they will not show up in the final scene. There are many approaches to set up a city layout with CityEngine. In this case, we will use satellite imagery to trace some street around Dorchester Avenue in Boston and use the resulting parcels to apply our building designs written in CityEngine's CGA language. For this, we have this handy feature called Get Map Data, which will take the current location of the scene on the world and query an ESRI cloud service, which will provide elevation and satellite images. So by providing an extent, the cloud service will generate the corresponding images, and CityEngine then will download them and import them into the scene as map layer type. You can adjust the resolutions for the image and the elevation maps individually. The resulting layer contains a satellite image draped over a quad mesh with elevation. So Boston is relatively flat, so the elevation is a bit hard to see. But if you look from the side, there's a tiny little hill there. So now it's time to have a first export to USD to set up the USD site. We select this new Terra layer and choose the model export with the USD format. You'll basically treat the terrain as a quad mesh model. The USD exporter does not have many options by design. The format is quite flexible and we implemented the broadly usable default behavior. The most important option for georeferenced scenes is the global offset, so to de-georeference them. Here we will center the exported geometry around the origin to prevent precision issues in Houdini later on. It is useful to round the offset to some rememberable values, and so we will be able to reuse them later in case you want to do more exports, and so that everything aligns. By default, the USD exporter will write a number of USD files with a fixed structure into the model directory. We structure the export by CityEngine layers and assets and tie it all together with a lightweight top-level USD file. Instanced assets will end up in separate USD files so they can be more flexibly reused. So let's step into Houdini. We use the reference lob in the Solaris mode in the stage view. So we browse to the models directory of the CityEngine project and select the top level model or USD file, I should say. So this will reference in all the data we have written out. This allows us to set up 2 cameras, for example, one for a bird's eye view and one for a street level view or whatever we like. In case you're wondering how Houdini found the satellite texture, we make use of the built-in USD preview surface material definition. I will explain this in detail later after we finished creating the streets and building models within CityEngine. Finally, we put down a merge node and pipe it through some Karma render settings node as well, so we are ready to render the scene at the end. So now that we have some scene content, we can also add some lights and just quickly see if Karma, the USD specialist renderer, is able to correctly light everything. So usually a dome light and a direct light for the sun. So there are different ways now to create the street layouts in CityEngine. One starting point is to take a look at tutorial 4 of CityEngine, which explains how streets can be imported from various data sources. Here, I'm going to take a different route and manually trace some streets on the satellite image. This is useful here as the number of streets is rather small. On larger scenes, it's of course more useful to import the streets, but this might involve some more work to massage the data sources, as there are not really worldwide standards on how cities store their street data. So by placing the camera into orthogonal mode and pressing the Y key to look directly from above, we can start to trace the street. CityEngine will choose some default values for the street and sidewalk width, but those can be adjusted later on as well. As only the crossing points are aligned to the terrain, we might see some terrain intersections, but we can also fix those by adding more nodes or points and align them with the terrain. For now, we just raise it a bit to have a nice view. There are also special tools to edit street and sidewalk widths. Now it's time to use the CGA rules. So now that we have basic street shapes in place, we can make them more interesting by generating actual geometry and detailed streets. To save some time here, we will make use of the complete streets rule, which is kindly provided for free by our community member, David Wasserman. This is available on GitHub. The streets polygons are set up by default with the necessary start rules, so the names for the rules for street, sidewalk, and crossing shapes. This means David's rules will work out of the box and we can just drag and drop the rule file onto the shapes. David's rules also come with a large number of parameters. For example, we can choose to have parking spots on the street. We can use the selection utilities to apply the rules for different shape types at once. These tools are also handy for other bulk changes like switching to a different rule file altogether for many shapes. So we select all shapes with the same set of start rules and apply the rules in bulk. And so we have now streets, sidewalks, and crossings. So finally, we end up with a street view with cars and trees. And it's all generated by the complete street rule project. The underlying street graph edges and nodes remain editable, and all derived geometry will adapt to changes. So if we move, for example, a crossing node, like here, the related geometry and the current dynamic street layer and its connected street rule will adapt and regenerate. So this is then the full scene with some more parameters turned on for cars and vegetation. Before we can continue with the buildings, though, we need to set up the parcels where the buildings sit upon. One approach is to refine the blocks which are automatically derived from the streets, so we can do a loop detection and find the blocks between the street. In this example, we make use of the built-in block subdivision schemes. We have 3 hard-coded subdivision schemes the recursive, the offset, and the skeleton subdivision. These loosely kind of map to practices of urban planners. Alternatively, we could also use the rules themselves to subdivide the blocks into parcels. For example, there is a rule called split area, which will create perpendicular cuts along a specialized direction, a specified direction. Of course, it's also possible to import or draw parcels directly, even with the attributes, so to control this building generation afterwards. We can always come back and adjust the subdivision of the blocks even after creating the buildings. So now we come to the main feature of CityEngine, which is the creation of procedural buildings based on the layers we previously created. As mentioned in the introduction, we will leverage the set of rules written by our VR team for the Boston planning project. The rule is modular in the sense that we can freely combine different envelopes, volumes, facades, and green spaces over different land uses. The rule can also create landscapes, parks, and even interiors. So let's continue in CityEngine by applying the rule on a parcel. We first start with like of a landmark, a high-rise building, the so-called Macy Tower. This is a fully procedural circular design, which can also freely be adjusted in width and height. For the rest of the parcels, we'll use some more generic building rule. Certain buildings as spec are driven by random values. So we can also regenerate these buildings with different random scenes. So here I will now click on the regenerate button to use a different random seed, and we'll see that the building design has a different upper floor design. So let's switch that back. There are many more parameters available. For example, there is one switch to change the level of detail of the greenery, of the vegetation. So here you see the building is regenerating with much higher density or detail vegetation models. So now it's time to export this new content to Houdini again. We use the same process as before. We select parts of the scene, either in the layer list on the upper left or directly in the viewport. Then we call up the USD model exporter again. We again provide a base name and reuse the same global offset settings as with the terrain, so everything will line up in Houdini. You might have noticed that we've selected some empty parcels. If these parcels have any rules assigned, the export will actually create the building geometry on the fly if it has not yet been created in the viewport. This is a neat little trick to export large scenes without overloading your GPU or system memory by the viewport. Let's switch over to Houdini and import this. We add another reference slope and merge it with the rest. We again select the top level file of our just exported building files. Let's disable the terrain temporarily and give Houdini some time to load the building. Here we go. Note that you have full freedom over the granularity of your exports. You could choose to export everything in one go from CityEngine or layer by layer. Thanks to USD compositing, the resulting scene graph in Houdini will be the same. We can also quickly switch over to Karma and do a basic first check if it looks more or less as expected. So you saw that we didn't have to do anything to get the materials in Houdini. And this is thanks to this USD preview material, which I want to explain real quick here. So in general, transporting materials and shading networks across applications is still a challenging thing. There's often a mismatch in attribute semantics or problems with duplicate materials. So luckily, with roughness metallic PBR materials in CityEngine and the matching PBR definition provided by USD, this problem has been solved, at least for this workflow here. CityEngine supports two material definitions, our legacy default one and the new PBR one. If the PBR is active in the rules, then our USD exporter will automatically create the USD preview surface shader properties for each exported USD object. This leads to a seamless experience, and the Houdini OpenShell viewport and the Karma will just work. Also, by adding, you can inspect the materials by selecting a part of a building, as you see here, and then you can navigate to the material properties in this stage in the scene graph of Houdini. So you see all the material properties there. And this really scales well for large scenes. Also, by adding a LOB material library, you can define your own USD preview surfaces, or of course also production shaders, and override parts of the CityEngine model by using USD techniques like the collection-based assignments and so on. So here you see the properties of USD preview surface once more. So now it's time to export a full scene, which will conclude these demonstrations. So these additional buildings are just static meshes without any materials from the Boston GIS database. So this time we export everything at once and bring it into Houdini. Again, it does not matter if you choose to export CityEngine layers individually or everything at once. You will have the same level of control in Houdini afterwards. This export contains about 50 million polygons, so a medium, small to medium scene, and it loads fairly quickly in the OpenGL viewport of Houdini. So it's certainly much faster than older formats. If more advanced performance control is necessary, you can also export CityEngine twice thanks to CJ in low or high-res mode and use LOBs or TOPs to switch between the two. Finally, we can switch over to Karma, as seen here, and explore the scene a bit more. Note how you can still quickly hide certain buildings and so also in Karma mode, sorry. And to conclude my part, here are some more final renders. Please excuse the missing sky here. And yeah, so after a few minutes of rendering, this looks like this. So it's really a seamless experience with the materials. And some more street level views here. So with this, my part is done and would like to hand it over to Ellie to talk about The Witcher.
Hello. Yes, so in The Witcher we used CityEngine, which massively sped up the process along with Houdini. There were only 10 days to do this. But yeah, the softwares as well as lots of code helped massively. Oops. Do you want to show a video, John? Yes, so CityEngine, Houdini, and Arnold were used with Python, as well as VEX, which is native to Houdini. Oh, come on. Okay, so this was the workflow overview. It started off with liaising with modeling. Again, as we only had 10 days, modeling needed to create a variety of windows and doors to be used. They exported 3 different file formats, which were used in the softwares respectively. And the reference we used was Carcassonne, which is a fortified city in the south of France, which is concentric by design. We used this idea with lower, middle, and upper tier style buildings in Sintra. So there are some pivotal things that the modeling department needed to keep in mind, which was, for example, the pivot point had to be at the lower center of the building, so that when the geometry was instanced in CityEngine, the window wasn't far away from the wall. The naming was crucial. We had asset type and variant, which was all we needed. And it was vital thus that this was consistent, as it was used repeatedly in scripts throughout the process. This is some more detail about the exported formats. the proxy geometry was literally a bounding box, and this was fed into CityEngine as an instance. It was incredibly fast to use because there was only not many polygons. The high poly geometry was loaded into Houdini as alembic pat instances, pat geometry, which only referenced one point in memory, which meant the scenes were much lighter. You were basically dealing with points which contained embedded data, or when I switched to the instance files, they were literally pointing to the AS file on disk. The AS file contains all data necessary to render the window or door, for example. This is something that Simon talked about earlier, the idea of CDA rules. So the scripts that I used was main, config, and assets. Some of the file names are explanatory. So the configuration file contained attribute data for, say, the width of the windows or the width of the doors. So where a building was a lower style, it might have less windows, and the buildings might be tightly packed together. The assets CGA contained paths to the directory of instance files to choose from, and the main CGA contained, well, it kind of wrangled everything together, was the attributes, rules, and styles. This is just an overview, more in situ, of parts of the code, or recreated codes that were used. This was using wildcards to point to the proxy geometries which the modeling department had made. The configuration file specified the lower ground height and the chances of there being 1 story or 2 story, etc. So an upper style building might have a 60% chance of having a 4th story created. And the main CDA file would import both of these files and wrangle them together to create buildings of different types procedurally. This is something that Simon also talked about briefly, which was the parameters. So the benefit of these parameters is that other artists could easily adjust these attributes without having to dive into the files that I showed previously. Then we have the rule data. There's always a stop rule. If the scope is set to have a lower class style or middle class style or upper class style, it says, yes, there's a class, I'm going to make a building, and then this will kind of waterfall into a series of rules. And if there's an instance, such as a window or a door, it says, okay, I want to go to this notable rule, which is pivot dummy. So the pivot dummy was used to recreate the orients in Houdini. And some data was also assigned to this pivot dummy, such as the instance file path and an ID, which was particularly useful for the shutters. So the modelers made roughly 8 variants of a lower styled window with several shutters which were either opened or closed to different amounts. So using the CDN value and some Python and VEX in Houdini, you could have more organic looking instances, which, yeah, a building will never have all of its shutters closed. This will have a variety of some open and closed shutters. Once the geometry was exported out of CityEngine as an alembic, in Houdini it was wrangled and separated into instance geometry, such as the doors, windows, other geometry, which was like windows, cornices, chimneys, drain pipes, and the roof planes. The roof planes were especially interesting because the tiles were scattered in an organized way. on top of the roofs and replaced with an instance file, an Arnold instance. And having so many tiles on all of these buildings added a really nice touch in a specular passes when lighting. With the instance geo, the pivot dummy, we created the orients, and the points could be using Houdini's instancing. You could also visualize what it would look like, and everything would be squished together into a collective AS file to be passed into lighting. This was the end result. So you can see the terracotta tiles, which are also a Roman feature in the city of Carcassonne. Got distinct U and L-shaped buildings. I think this is the middle class because it's mostly 2 to 3 tier buildings, 2 to 3 floored buildings. And in the background, you have more tightly packed lower class buildings. So given that there were only 10 days to create a city, thanks to CityEngine and Houdini, they did, well, and Arnold, they did an incredibly good job. So yeah, thanks for listening to my presentation. I'll stop talking. I'll hand it to you guys.
Great. Thank you to Taisha, Simon, and Ellie for a fantastic presentation. We'd like to open it up to any Q&As that are coming through on Zoom Q&A and also Facebook Live. So please submit your questions and we'll have them answered for you. Would like to also point out that this recording will be posted shortly after the conclusion on the CityEngine TV YouTube channel. So look for that, and you can always replay again on the VES New York section Facebook group. So we have a few questions that came through. So one is, can you create rules for material assignment within CityEngine? So I would like to take that.
Yes, for me, I guess. Yeah, so the material assignments are actually, or the material properties, I should say, are like any other properties on CityEngine models. So you can fully control them with the CGA rule or language, I should say. And as mentioned, by switching to the PBR material type, it will then automatically create the USD preview surfaces in the USD exporter and will just work in any USD consuming application down the pipeline.
Great. Follow-up question, very similar. So it basically just plays off what Simon said, is basically randomly assign materials based off rules, assuming that CGA rules have randomization built in. It should be fairly straightforward.
Yeah, it's the same technique. You can use the stochastic part or the random part of CGA to control any attribute, including the materials.
I have a question while we're waiting for a few more to come through. Given the industry adoption of USD, what was one of the challenges that you faced while going through this standard that is evolving actively within the community?
So specifically, there was still a lot of a bit of maturity issues, I would say. So a lot of viewers of USD had still a lot of problems with displaying the preview materials correctly. But otherwise, actually, it was pretty smooth sailing. The work by Pixar and Co. and partners is exceptional. And the API specification and documentation is also very great. And there is also a great community. Usually you got answers very fast if you posted a question to the USD interest mailing lists and like that. Yeah, so that's from a point of view of a developer, of course. I'm not the artist, so I wouldn't know how it is to work with USD really on a really high-end production, but I love to hear the feedback, of course.
And as we have a very proficient artist here with us, Ellie, what was your experience with CityEngine and getting up to speed to the point where you were ready to execute on a large-scale production?
So that was the second time I had used CityEngine. The first time I used it in a very different way. I think it was similar to Blade Runner. It was the first time I'd used it in the sense that they were fitting buildings by asset best size, using a load of case else statements within the CGA rules. But that workflow, well, the learning curve I found very steep. Probably took me about a month when I was a junior artist looking into this. But then the second time round with Sintra, I felt like I was using it how it was meant to be used, like creating buildings from scratch. You started with the scope, you extruded upwards. For each facade, you would split and then assign instances, etc. I wasn't using the USD method, of course, or there were some other workflows that would have been much better. But for 10 days and to be able to look at the many tutorials, it's pretty good the second time around.
Great. We have a question, actually 2 parts coming in that says, how do you get the buildings to have the doors facing onto the street? Is there a built-in function that points the, quote, front of the building to the street, or do you create your own script?
So what's usually been done is that buildings are modeled, or pre-modeled buildings are modeled in a way that they have like a convention. So the front is like along the x-axis. And then you have tools in CityEngine to get to that x-axis or orient the parcels with the x-axis, the local one, to the street. And then if you put down the building, it will look the right way. And maybe just to expand on that, you can also query like proportions and things from such assets. So you can also choose between multiple options. If you have like 7 pre-modeled buildings, so you can choose the one which has the best proportion for a certain parcel.
Great. That leads to a second question, which deals with how do you deal with buildings that are supposed to be butted up right next to one another, like New York City tenement buildings?
So, sorry, Ellie, did I?
Sorry. So I did lots of terrace buildings in The Witcher. You just extrude up normally without any setback. There's a setback function which you can use. Yeah, sorry, you continue, Simon.
Got me there. So what you can also do in CGA is you can query between buildings. We call that occlusion checks. So you can actually, if you want to build a balconies in one building, you can actually first check if there's not another building in the way, and then you can leave out that balcony in that case.
Great, and also checking to see if any of our viewers on Facebook Live have posted. As Ellie mentioned, there is a multitude of great tutorials available. Primarily, one of the best resources to check out is the CityEngine TV YouTube channel. Taisha does a fantastic job of curating content on there. We will be providing a link very shortly. But that is probably the first place you should check besides the wonderful documentation. And as a CityEngine evaluator, I must say kudos to the documentation writers. It is always very thorough, kept very up to date with the latest advancements. So
Matt will be happy to hear that. He's our doc writer. Yeah, so definitely CityEngine resources page. I'm guessing that's also what you're referring to with the documentation and the YouTube channel. If you want to just kind of, yeah, see a few tutorials, obviously live on YouTube, or also, yeah, I have like I guess I'm trying to find like tips and tricks and things like that, things that are interesting or could be interesting. So I'm also always interested in feedback from people, what you actually want to see on that channel that might be more helpful.
And should also mention that the ESRI User Conference is coming up virtually this year. It will be held from July 13th to the 16th. So wonderful developments and new discussions to take place there. So if anyone is interested, they can check out ESRI's user conference page. We have a question from Facebook, which is, are there any changes in licensing coming in the future? Indie licenses, perhaps?
Not as far as I know, to be honest. But I'm not really deeply involved in that part of the product. So I would we can certainly check on that and get back to this to the person who put the question. Before I give any wrong answer, I would like to check first.
Well, we should also say that there are currently evaluations available for CityEngine, and that will segue us towards the end of our webinar here. We are also hoping to provide an additional part in this particular series, taking a deeper dive looking into the workflow within Houdini with the Palladio toolkit, plugin toolkit, which provides direct access to CityEngine data from within the procedural network of Houdini scenes. And we'd also like to get your feedback and see if there's any interest in seeing some interoperability discussions and features you'd like to see with CityEngine and game engines. So please, we will be sending out a questionnaire following the webinar, and if you'd like to provide any critique or anything you'd like to see, please send us that information. And with that, I will post this final image for everyone, and I want to thank
John, someone's asking where they can find the recording of this webinar.
Right. The recording will be available on the CityEngine TV YouTube channel, and we will also provide that link out. But I want to thank everyone, our panelists, for joining us today. You can reach them at their email addresses, and you also see the release highlight notes for CityEngine 2020, Ellie's website listing her work, as well as a VES New York contact information. So all of this will be sent out to all of our attendees. So once again, I want to thank all our panelists and thank all our attendees, and see you soon.
Thank you, John, for organizing.
Yep, thank you, John, and thanks to everyone who joined today. Thanks for your time.
Yep, and thanks, Taisha, and thanks, Ellie.
Yep, thanks
to all
Ellie and Simon. Thank you all. See ya.
Okay, bye-bye.
Bye.
Bye.